Let's work through the guided worksheet for Week 1, Section 1.2. You should print out the blank copy of this guided worksheet and read it and work through the problems on your own before going through the solutions in this video. The two topics in this section are linear equations and rational equations. We're going to study the differences between the two and go over some solution methods. Let's take a look at solving linear equations. A linear equation in one variable is an equation of the form ax plus b is equal to 0, where a and b are real numbers and a cannot be equal to 0. Let's take a look at this first problem. What we'd like to do is we're going to solve two linear equations for x, and then we'll check our answers in each case. In problem A, our first step would be to simplify each side as much as possible to determine a solution for x. Nothing to do on the left side. On the right side, we're just going to distribute that 3 to each part. And then we have to distribute this negative sign to each part in parentheses. So our first line should look like this. If we combine like terms on the right-hand side, we're going to end up with 16 is equal to 2x plus 4, 12 is equal to 2x, and x is equal to 6. So we see in this case, we have one solution. Now to check our work, we're going to take this solution and plug it into the original equation for x. Once we do that and work through the math, we indeed get 16 on the right-hand side. That tells us that x equals 6 is a solution to the original equation. If we were to move everything over to one side, to the left side, let's say, and simplify, we could then, have this linear equation be of this form with the 0 on the right. It's not necessary to do. Just wanted to point out that it really is a linear equation because we can write it in this form. All right, here's another problem. In part B, this problem is also a linear equation. The only difference is we have some fractions. So we have some numbers in the denominator. If you'll recall from your prerequisite knowledge, the way to kind of simplify a problem like this is to clear the equation of any fractions. So that means we're going to multiply by the least common denominator. The least common denominator in this case would be 28. So we need to multiply both sides of the equation by 28. That means we need to multiply each term on both sides of the equation by 28. Once I do that, we'll see the 4 goes into 28 7 times, 14 goes into 28 2 times, and 7 goes into 28 4 times. So each of those denominators will cancel, they'll be cleared, and we'll be left with what's in the numerator times that extra factor. That's what we get in this second line. After we combine like terms, something that you're familiar with, and then work through the simplification process of just getting the x on one side by itself, we end up with x equals 1. So again, we see here for this linear equation, we get one solution. What we will do is we're going to plug in that solution, which happens to be x equals 1, into x on both sides, and we should, if it is a solution, which it is, we should get the same value on both sides, which we do. All right, next let's take a look at solving rational equations. All right, when we solve the equation in problem 1 part B, remember this was the linear equation that we had, it had constants in the denominators. Well, the difference between a linear equation and a rational equation is that a rational equation includes at least one variable in the denominator. You can also have variables in the numerator. Right. So let's take a look at problem 2. We're going to solve the rational equation given here for x. Notice it's a rational equation because we have variables in the denominator. We have a variable x, whereas if we go back up here, this is a linear equation because we don't have any variables in the denominator. Both equations have variables in the numerator. Okay. What we need to do first, whenever we're dealing with a rational equation, is to check for restrictions on the variable. What this means is we have to avoid any values of the variable that make the denominator 0. So let's set each denominator that involves a variable equal to 0. So we'd see 2x is equal to 0 and 3x is equal to 0. When I solve for x, I will get x equals 0. Also, here I get x equals 0. So that's our restricted value. Since it makes the denominator equal to 0, it can't be a solution to this problem. So let's try to find out what the actual solution is. What we're going to do is we're going to multiply both sides of the equation by the least common denominator. This is something you should already be familiar with. So the least common denominator of 2x, 18, and 3x is 18x. Notice it is not 18x squared because we just have an x here. You don't multiply the two x's, we just take one of them. All right. When I multiply each term on both sides of the equation by 18x, it simplifies to this next line, and eventually we get down to 51 is equal to 17x, or x equals 3. All right. Our next step would be to just verify, right, that our solution we got is not one of the restricted values, and it's not. Since x equals 3 is not a restricted value, meaning it is not 0, it must be the solution of the equation. We can check this in two ways. We can check it by hand like we've done in previous problems, right? Substituting in x equals 3. Remember, you're always substituting that into the original equation. Or a more convenient and easier way to do it would be to enter this into the home screen of your calculator. So here, the left-hand side, I'm just plugging in for 3 for x. Same thing on the right-hand side. We notice that we get the same values. So thus, x equals 3 is the only solution to this problem. All right, in problem 3, what we'd like to do is we need to find the values of x for which y1 is equal to y2. And we're given what y1 and y2 are. So what that means is we have to set y1 equal to y2 and solve for x. The next step in our process is to find the restricted values. Remember, those are the solutions that x cannot be because they make the denominator equal to 0. So we're going to set each denominator equal to 0 and solve for x. One denominator is x plus 4, the other is x minus 4, and then the other denominator is x squared minus 16. Recall that we can factor this. So x squared minus 16 is x plus 4 and x minus 4. Basically, those are the same denominators, right, that are on the left-hand side. So that would mean when I set each of those equal to 0 that x equals minus 4 and x equals 4 are the restricted values. Right? So if we were to work through the solution to this, which we will in a moment, and we were to get x equals negative 4 or x equals 4 as a solution, right, that would actually mean there were no solutions to this problem because they are the restricted values. Let's see what values we actually get. All right, what we're going to do is we're going to find the least common denominator. Remember that x squared minus 16 factors into x plus 4, x minus 4. So what we need is one factor of each for our least common denominator. Here, we multiply that on both sides of the equation. Right? Notice that on the left side, we need to take this product and distribute it to each part since there are two terms here. All right, so if I take x plus 4, x minus 4 and multiply by the first fraction, the x plus 4s are going to cancel. I'm just going to be left with x minus 4. If I take this product and multiply it by the second fraction, the x minus 4s will cancel. And I'm going to be left with x plus 4. On the right-hand side, these all 4 cancel, and I'm just left with 22. Or, when we work through that, that means x is equal to 11. Okay, since our restricted values here were x equals negative 4 and 4, and x equals 11 is not one of those, it is the solution. All right, Now, what criteria do we have for determining whether an equation has a solution, and maybe what kind of solution does it have? Let's go over 3 possible categories. An equation that is true for at least one real number, meaning we get at least one solution, is called a conditional equation. The problems that we've looked at so far have all been conditional equations because they've had one real number as a solution. However, if we encounter an equation that is true for all real numbers, it's called an identity. And if we have an equation that is not true for any real number, it's called an inconsistent equation. We've already looked at a few examples of this first part, a conditional equation, right? Let's take a look at some problems involving what's called an identity or an inconsistent equation. So we're going to categorize them into either one of these categories, these types. Right? In problem 4, when we're asked to categorize something, what that means is that we basically want to simplify the equation as much as possible on either side and just see what falls out. What do we get? And let's try to make sense of it. Nothing to do on the left side. On the right side, I'm going to distribute this 4 and simplify. So I get down to this step here. Notice that the 4x's will cancel, and I'm left with a statement that says -7 is equal to -1. That's clearly a false statement. That means that this equation has no solution, and it's called an inconsistent equation. So it's not true. No real number, any real number we put in here no real number will make this equation true for any value of x. If we do a similar thing now with problem B, we can distribute the 9, collect like terms. It turns out that when we look at the variables, right, the 7x's cancel and we get 9 equals 9, which is a true statement. So that means that the solution set of this equation is all real numbers. Any real number we put in on the left, and if we put that same number on the right, the left and the right sides are going to always match. So this equation is called an identity. The last thing I want to do in this section is to look at some modeling problems, some application problems. You're going to see throughout this course that we do that. So the first one involves people with a low sense of humor, right? It says that people with a low sense of humor, I guess that could be not no sense of humor, but very slight, have higher levels of depression in response to negative life events than those with a high sense of humor. This can be modeled by this formula. Notice this is a what? It's a linear equation, right? This x is in the numerator. All right. X represents the intensity of a negative life event, and D is the average level of depression in response to that event. If the low humor group averages a level of depression of 10 in response to a negative event, what is the intensity of that event? All right, so what is given is D is equal to 10. So we have to set D equal to 10 and solve for X. So I set that in the equation on the left side. The least common denominator is 9. I'm going to multiply the equation on both sides by that. We end up with X is equal to 3.7. We can write a small short sentence that says the intensity of the event is a 3.7. There aren't any units given for this one. It's just really a level. Okay, so that's applying what we've done with linear equations, right? Now, this is a new problem. It's really an introduction to section 1.3, and I'd just like you to think about it. So suppose we're choosing between 2 texting plans. Plan A has a monthly fee of $15 with a charge of 0.8 cents per text, and Plan B has a monthly fee of $3 with a charge of 12 cents per text. Let's write 2 linear equations that model the situation. So if X is equal to the number of texts per month, we've got 15 plus 0.08 times X for Plan A, and 3 plus 0.12X for Plan B. If we need to figure out how many text messages, for which the number of text messages, the cost of the 2 plans will be the same, we need to set them equal to each other and then solve for X. Once you work through this, you get X equals 300 texts. So the cost of the 2 plans will be the same for 300 text messages. All right, this sets us up for what we're going to be doing in section 1.3, and this ends this guided worksheet.